Welcome to This Explainer. Today, we are diving right in and unpacking the black box of fully autonomous AI. You know, we hear the term AI agents thrown around literally everywhere in tech circles these days, but what actually goes into making them tick? Well, instead of just talking about abstract theory, we're going to look at the actual literal blueprint of a digital workforce. Think of it like taking a VIP tour of a modern factory, but the twist? The workers are made entirely of code. Let's get into it.
Here's the game plan for our explainer today. First, we'll look at the evolution of automation. Then, we'll cover infrastructure and core brains. After that, building the agent workforce, and we'll wrap up with the AI supervisor.
All right, let's kick things off with part one, the evolution of automation.
Man, looking back, it's just a fascinating journey of sheer developer willpower. We started way back in 2004 with JavaScript Runner, and then slogged through various iterations of Selenium all the way to 2019. For over 15 years, automation pretty much just meant rigid manual scripts. You had to hard code literally every single step in an IDE. And you probably remember this pain. If a website moved a checkout button just a few pixels to the left, boom, your entire script would crash in a fire. It was incredibly brittle. But mapping out this timeline really highlights just how massive the leap is to today's dynamic AI models. These new models actually understand their environment, rather than just blindly following rigid instructions.
Moving right along, let's get into part two, infrastructure and core brains.
Okay, so you absolutely can't build a dynamic AI workforce on a weak foundation, right? For our setup here, we're using a serverless architecture on Azure. And this is a big deal because it gives us instant auto-scaling. Basically, our digital workforce can immediately scale up during heavy traffic to get the job done, and then scale right back down to save us costs. Now, the core engine running all this, it relies on OpenAI's large language models, specifically GPT-4o and its mini version, to handle the heavy lifting of complex conversations and fallback mechanisms. And for the system's memory, we're utilizing Azure Cosmos DB with a MongoDB API that lets us store all that messy, semi-structured data fluidly and quickly.
Thinking about how this entire system maps out, it really is quite something. Everything kind of orbits a central hub. On one side, we've got our core functional components, so the natural language processing, the conversational flow, and the business logic. Then, on the other side, the cloud architecture is there ensuring the whole thing scales perfectly. And beneath all of that, our database integrations plug right in to keep the data flowing. It forms this highly organized ecosystem where information just moves seamlessly between the AI's brain, the highly scalable body of the cloud environment, and its memory banks.
That brings us to part three, building the agent workforce.
Time to meet our first specialist on the assembly line, the model matcher. You know, traditional automation used to rely strictly on exact keyword matches. Like if a user accidentally typed iPhone instead of iPhone, the script totally broke. Well, the model matcher is vastly smarter than that. Its specific role is to take a vague product name or even a super messy model number, figure out what the user actually meant, and output perfectly matched data. It's essentially acting as a frontline detective, making absolutely sure the system starts off with accurate information from the get-go.
So once the matcher finishes up, the attribute validator steps in. This agent sifts through the matched items and strictly verifies what features actually exist for those specific products. Think of it like a rigorous QA expert that's filtering out all the noise. And honestly, this strict specialization is exactly why agent-based systems are just so powerful. Instead of having one giant AI model getting completely confused trying to do everything at once, each individual agent is laser-focused on doing just one thing exceptionally well.
And that leads us to our final specialist, the comparison conductor. This agent takes those meticulously matched and validated attributes we were just talking about and actually uses them to build the ultimate comparison table. It analyzes the differences and the similarities across the data, and then it outputs a perfectly formatted table. The result? A human user can instantly read it and actually use it to make a quick, informed decision.
Now, walking through this sequence in action shows exactly how a concrete workflow operates. First, in step 1, the model matcher aligns the numbers. Then, in step 2, the system pulls the possible attributes. Step 3, the attribute validator rigorously filters them out. And finally, step 4, the conductor executes the final comparison. It's a lot like a relay race. By passing data cleanly and sequentially from one specialized tool set to the very next, we drastically reduce the chance of the AI hallucinating. It's really a highly controlled digital assembly line.
All right, let's move into our final section, part 4, the AI supervisor. Now, you might be wondering,
how do these individual agents actually know when it's their turn to act? Well, that crucial job falls to the supervisor agent. Now, the supervisor doesn't actually do any of the data matching or comparing itself. Its entire job is delegation. It utilizes a framework called LangGraph, which is specifically designed to manage complex, cyclical AI workflows. So the supervisor is sitting there monitoring the state of the task, deciding which specialized agent is needed next, routing the data, and ensuring the whole process doesn't get stuck in some endless loop. It is literally the maestro of the digital orchestra.
So we've traveled from the incredibly brittle, hard-coded web scripts of the early 2000s all the way to a dynamic workforce of specialized AI agents running seamlessly on the cloud. We've met the individual workers and the supervisor that holds the whole operation together. But as we wrap up this explainer, I'm going to leave you with this provocative thought. If we can construct a digital workforce today that manages its own tasks with this level of precision, what happens to the enterprise when these multi-agent systems start building even smarter agents themselves? It's a wild frontier that is going to redefine work entirely. Thanks for joining me for this explainer, and keep questioning the future.